So today we are still going to be solving linear equations, but instead of just solving sort of abstract equations, we're going to solve word problems that require a linear equation to solve. So the challenge is really not so much going to be on the solving end of it, but it's rather going to be like the setup. Because if you don't set it up correctly, you could do all the algebra correctly and still get a wrong answer, right? So a stated problem is known as basically like a word problem. And what we're going to focus on first are different vocabulary terms, some key terms you want to look out for to help you set up these equations. Now, once we solve the equation, we'll write our answer. And we'll just make sure that we're answering the question that's being asked. So like if the question is like about a dollar amount, we want to make sure to write our final answer with a little dollar symbol. Or if it's talking about like gallons, you put gallons of water or whatever the context is, usually just saying something like x equals 6. That's good, but you're going to want a little bit more detail. Usually you can find what you're actually trying to solve for within the problem. It'll be worded in such a way to where, just kind of rewrite the question that's being asked, and that's going to be how you write your answer. But we'll get into all that. First, I just want to go over a few terms that you should probably be familiar with as you're working as a sort of English-to-algebra translator. You're going to be reading the word problem and just kind of slowly picking out terms that can be represented symbolically with an equation. So like addition, for instance, as you're reading the problem, there might be a few different terms you want to look out for that indicate that you're trying to add things together. The word total is a pretty common one. Probably the most common one you'll see is a word that's called sum. If it's ever asking you to find the sum of two numbers, that's telling you to add them together. One phrase that's used sometimes is this phrase more than, although I want you to be a little careful with that phrase. Like if I say you have X apples and I have 3 more than you, you can set up an expression for me that's 3 plus X, right? But more than can mean something different in a different context. For example, like if I say I have more than $3, then that's more of an inequality where it'd be like X is greater than 3. So you definitely have to make sure you're understanding the context of the problem. And don't just automatically assume that when you see more than it means plus. Now today we're not getting into inequalities yet, so it will mean plus if you see that. But like when you actually take the real TSI, all the problems are going to be mixed together. And so you just really want to be careful on, well, is this actually like a greater than, or is this like asking you to add two things together? And it shouldn't be too too confusing. Like it should be pretty clear once you read the problem, but just want to call that out as be careful with that phrase. For multiplication, there's a few terms you should be on the lookout for. One of them is the word of. It seems like, oh, how does that, it's kind of weird that would mean multiply. But if I say I have like 3 groups of something, that means I have 3 times that amount. So if you ever see the word of, or sometimes like we're not going to get into percents quite yet. We'll get to that in a future unit. But we start talking about percents. You might set up an equation like what's 20% of 100? And so you write it out as like 0.2 times 100. So you see that word of, quite often that means multiply. Again, not always. There's a little bit of context with that one, but more often than not, that's going to mean multiplication. The word product is something that's going to mean to multiply. If it's asking for the product of 2 numbers, it just means multiply them together. And then sometimes you'll see like a very specific multiplication, like the word twice, for instance, means multiply it by 2. So it's like 2 times. That's really, I guess, the main one. Otherwise, we'd say like 3 times, 4 times. But just, twice is something you want to know. For subtraction, we've got difference. Like if you want to find the difference between 2 numbers, you're going to subtract them. Like the difference between 10 and 8 is 2, because 10 minus 8 is 2. You might see the phrase less than, and I want to put a little asterisk on this as well, because just like more than, this might indicate an inequality, where if I say I have less than $10, you would say X is less than 10. But if I say, like, you have $10 and I have 3 less than that, there's no inequality there. You're just going to subtract 3 from your amount. So just, you want to be a little careful with that one too. Probably not going to be a ton of division. It might just say divided by or something like that. But really the main term we want to be looking out for is quotient. If you want, it's asking you to find the quotient of 2 numbers. It's asking you to divide them. And finally, equals. This is a very important one. Yeah, like, where do you put the equal sign? Sometimes it'll just say equals. Sometimes it'll be as simple as the word is. That's probably the most common one. Something is something. So if it says, like, you know, the price of the shirt is 20% of $100. I don't know, just throwing out numbers. The is where you'll put that equal sign as you're writing the equation. You might also see the word equivalent. Okay, equivalent, equal, kind of the same thing. Any questions about any of these terms, or can y'all think of anything else that we should throw in there? Those are kind of the ones I came up with. Yeah, if anything.
For division.
Yeah, fraction. Okay, yeah, fraction. A fraction of, I like that, a fraction. Okay, so any fractions is really just division.
Percentage of as well.
Yeah, so a percent, so we'll come back to percents later because it's a little tricky. The way it's worded, say something is a percent of something, not only do you have to divide by 100, but then you have to multiply by what it's a percent of. So it's a little bit of both division and multiplication. But don't get too worried about the percents. We'll get to that when we get to that. So let's try some examples where we've got essentially a statement, and we want to try to act as a translator here. You know, just think of algebra as just a different language. Yeah, and we're going to translate this from English to algebraic. And I'm just going to break it down like one phrase at a time. Okay, you just want to read it very slowly, because if you set it up incorrectly, you're sort of doomed from the start as far as trying to get the right answer. So this says the sum of. Okay, so I know I said of was multiplication, but context is everything here. It's saying, in this context, it's saying the sum of. This is our indication that we are going to be adding. Okay, the sum of a number x, so that's x, and 7. So the sum of a number x and 7. Maybe I'll just kind of highlight this. Okay, so that would be like, okay, x plus 7 is, that's going to be our equals, 14. So the way that we're going to want to set that up, maybe I'll zoom in here a little bit so you can see that a little better, is the sum of a number x and 7, so x plus 7 is 14. And so we can solve that. You know, you guys just took a quiz over this, so you know, hopefully the solving is kind of the easy part, and it's the setup that's really the more challenging part. But here you would just subtract 7 from both sides and get x equals 7. That's it. Yeah. Sometimes the questions just ask you to set it up also. Like, which of the, like, if it's a multiple choice question, it might say something like, which of the following is an expression that could represent this scenario? All right, number 2, twice the sum of x and 7 is 14. So twice, meaning we're going to multiply by 2. The sum of x and 7, meaning we're going to add those things, two things together. So twice the sum of x and 7 is 14. And then we could go through the motions to solve it. This is going to require the distributive property. So we'll distribute that too. Get 2x plus 14 equals 14. might already be able to figure out what the number is going to be. But if you're showing all the steps here, we're going to subtract 14 on both sides. And that leaves us with 2x equals 0. So it should be pretty obvious what x is going to be now. If you divide both sides by 2, you're going to get x equals 0. Any questions so far? Okay, number 3. The difference between w and 22 equals 3 times w. So difference is indicating subtraction. And it says between w and 22. So the difference between w and 22 is w minus 22. Equals is pretty self-explanatory there. And then 3 times w. There's another multiplication word we didn't write down, times. I'm guessing you guys probably know that times is going to be multiplication. So you could add that to your list or not. So 3 times w. On a problem like this, I would start by subtracting 3w from both sides. And that is going to leave us with 0 on the right-hand side. So w minus 3w would be negative 2w minus 22 equals 0. Adding 22 to both sides. Will give me negative 2w equals 22. And then finally, we divide both sides by negative 2. So w is negative 11. I definitely want to encourage you to use your calculator as you're working these out. You're going to have access to it, so you may as well take advantage of it. Okay, number 4. 4 times the number x is equivalent to the sum of 2 times x and 14. All right, so let's be careful here. 4 times the number x, so that's 4x, is equivalent to, that's equals. And the rest of this, we've got to be careful how we set it up. It says the sum of, so that means the next two things it says we're going to add together. So the sum of just says, hey, get ready, we're going to have an addition here. 2 times x and 14. So we're going to add 2 times x and 14. And once you got it set up, once again, we just sort of go through the motions here, use those properties of equality. Don't really want to focus too much on that today because we already went over that last time. What do we get here? 2x equals 14, so x is going to be 7. Any questions? All right, let's keep going here. So here's kind of your path to victory here. Okay, read the problem carefully. That's like just slow down. Just keep in mind, like the test is not going to be timed, so you're not up against the clock or anything. Just take your time reading it. Go through and clearly like mark the key words that you're finding, like sum, product, all those kinds of things. Figure out like what is it actually asking you. That can give you a big clue as far as like what should your like x or your variable be. If like the first problem saying, how many stickers does James have? That should be our x. Okay? Set up the equation and then solve it. So let's take a look at kind of an example word problem here. it says Sarah has $5 more than, oh, $5. I think that's a typo there. Let's just scratch out that dollar sign. That doesn't make sense. Sarah has more than twice the number of stickers that James has. If Sarah has 29 stickers, how many stickers does James have? So the question here is asking, how many stickers does James have? That's going to be what our x needs to be. X will be the number of stickers James has. And so that's really what we're trying to figure out anyway, right? Welcome. Oh, no problem. So let's try to set up this equation. It says Sarah has 5 more. So this 5 more than means we're going to add 5 to whatever comes next. Twice the number of stickers that James has. Well, the number of stickers that James has, that's our x. So it's going to be twice x. So 5 more than twice the number of stickers. So this is twice the number of stickers James has. 5 more of that, 5 more than that. And then it says Sarah has 29 stickers. So that should equal 29. Now we've got a nice little two-step equation where we can subtract 5 from both sides. We got 2x equals 24. And then if we divide both sides by 2, we get 12. And like I was saying a little bit ago, that's good if you can get that far. I'm pretty happy about that. But you do want to be able to answer the question in the context that it's being asked. So in other words, okay, x equals 12, but what does that mean? The question that's being asked is how many stickers does James have? So that's how we want to answer the problem. We want to say James has 12 stickers. That way you're clearly identifying what does that variable represent. Any questions? All right. Now, one thing that comes up from time to time is this idea of consecutive numbers. Every once in a while, I'll see a question where it's like 2 consecutive numbers have a sum of 20. Well, I guess that couldn't happen. But about 2 consecutive numbers have a sum of 9 or something like that. And so your job would be to figure out what those numbers are. But if you don't know what consecutive means, you're kind of doomed from the start. Yeah. So consecutive numbers are numbers that come right after each other. So 3, 4, 5 are consecutive. But 3 and 8 are not. So they're just numbers that come right after each other. They follow each other in order. So the way that we want to express consecutive numbers is just like if, let's say, x was the smaller of the 2 numbers. So for example, let's say 10 and 11. If x is the smaller number, then what's the next, how do we express the next number, the next consecutive number in terms of x? X is the smaller number. Yeah, x plus 1. Okay, this would be the next, or this would be the smallest number, and this is the next consecutive number. Consecutive, can't spell. And so on. Then the next one, so if x was 5, x plus 1 would be 6. What would be the next consecutive number? So if we have 5, 6, 7, if 5 is x, so x and then x plus 1, then how do we get to the next one? Yeah, just add one more, right? So x plus 2. And so depending on what the question's asking for, you might have to set up an expression that involves like x plus 1, and most of the time it'll be something like 3 consecutive numbers add up to this. What are they? Or what's the smallest number? Something along those lines. It might also ask you about consecutive even or odd numbers. And those are going to be set up kind of the same way. Even numbers are numbers that are divisible by 2, and odd numbers are ones that aren't. So even numbers are numbers like 2, 4, 6, 8, 10. Odd numbers would be like 1, 3, 5, 7, 9. But whether you're talking about even or odd numbers, they're always going to be like separated by like one number that's missing in between. So like if we're talking about even numbers, for instance, and the smallest number is x, to get to the next consecutive even number, from 2 to 4, instead of adding 1, you'd add 2. So like if the smallest number is x, the next consecutive even number would be 2 more after that. So it'd be x plus 2. And the one after that would be x plus 4. And this works for even and odd numbers. So you don't have to really worry like which one is it, because it should work out for you. So this x plus 2 is the next consecutive even or odd number. All right, it'll be essentially like 2 numbers after the first one. So here's the kind of problem that you're going to face as far as consecutive numbers go. Something like the sum of 3 consecutive integers is 75. What are the numbers? So you need 3 numbers that are right next to each other that add up to 75. Now, you might just be able to figure it out, right? Like you could just it's not going to be 1, 2, and 3. That doesn't add up to 75. It's not going to be 100, 101, 102 because that's way too big. And you could kind of figure it out, I think. But if you're going to set it up algebraically, you would have the smallest. So we've got 3 numbers, 3 consecutive numbers. The smallest one would be x. The next one would be x plus 1. And then the next one, the third one, is x plus 2. And what the problem's saying is that the sum of them, in other words, if you add them up, you get 75. So we've got x plus 1. Maybe I'll do that in different color just to illustrate this a little bit. X plus 1 plus x plus 2. So this is like the first number, the second number, the third number, equals 75. Now, if I solve this equation, I am going to get x. So I'm only going to get one of the 3 numbers. But here we're letting x be the smallest number. So if we get one of them, we could figure out the other 2 by just incrementing by 1 to get those next 2. So here we're going to combine like terms. X plus x is 3x. 1 plus 2 is 3. So we have 3x plus 3 equals 75. We could subtract 3 from both sides. We get 3x equals 72. And then finally, we're going to divide both sides by 3. This is where even old Mr. Schuler is going to break out the calculator here. 72 divided by 3. Or maybe you guys can do it for me. It's 24. Okay, so we got x equals 24. We did all the algebra right, but we got to make sure we're answering the question that's being asked. What are the 3 integers? And here we're letting x be the smallest one. So the next consecutive integer is 25. And the next one's 26. And you can even check it. Like if you add those 3 up, it should equal 75. Let's go ahead and finish up here. We got one more problem before I start getting you to work on your own. It says the sum of 3 consecutive even numbers is 48. What are the numbers? So they're consecutive, but they're also even. So instead of being like 1, 2, 3, 4, 5, it's 2, 4, 6, 8, 10. In other words, each number is 2 away from the previous one. So if the smallest number is x, the next number would be x plus 2. Like if the first number was 2 and the next one was 4, it's 2 more than that. And then the next one would be x plus 4. So you have like 2, 4, 6. 6 is 4 more than 2. And it says the sum of those three numbers. So here's our three numbers. The sum of them is 48. So you can see once you get it set up, you're going to solve it just like the last one that we did. Combine our like terms. So we still have three x's here. Combine your constants. So 2 plus 4 would be 6. So plus 6 equals 48. And just like with the last one, when you solve this, it's going to give you the smallest of the three numbers. So just be careful when you write the three numbers because they'll have to be even. So let's solve this. We'll subtract 6 from both sides. So we have 3x equals 42. And then we need to do 42 divided by 3. Ran out of room again. So x is going to be, is that 14? 14. Okay, so this is 14. And again, that's the smallest number. So that's not like your overall answer. We want to know like what are the three consecutive even numbers. So 14 is the smallest one. Then we have 14, 16, and 18. And you can check that in your calculator to make sure that it's the right answer. But if you do add 14 and 16, I guess that'd be 30, plus 18 would be 48. So it definitely checks out. Well, that's about it for today. Oh, yeah, you got a question? Oh, no. Yeah, no problem. That's about it for today.